And we're actually going to, at this moment, start going into our next topic, which is architecture and components. It's like Legos, but for building stuff our customers use. I really do look at Azure components and services as Legos from an application architecture and composition perspective. Who in here has heard of microservices, nanoservices? I just made that one up, but really small microservices. It's when we're thinking cloud, you now have to stop thinking about the traditional methods of doing things. Yes, I could put this on a server with Windows on it, with IIS, and deploy it out and scale it like I normally do. But we're going to talk about a lot of the architecture bits that we can really leverage the power of the cloud to think beyond that. So you're going to think small, little, bite-sized chunks that can work together to build really powerful applications. We actually used a couple of different ones in this application. We're going to go talking about it. So the client that you guys saw out there, so the voting app has two parts. It has the client and the back end. Okay, the back end are what's processing the votes, and the front end is what's giving us that page. Thinking about the client, and again, I'm thinking components here. I'm thinking, how can I piece this together to make this go out quickly? I want to optimize my cost. I want it to be secure. I want it to be reliable. And your four pillars of architecture when you're thinking cloud, reliability, security, performance, and cost optimization. If you take nothing else away with you from this morning, those four things, four pillars are super important. There's a paper written by AWS, which is a great paper for cloud architects called A Well-Architected Framework. Talks about those four pillars. The four concerns that you have are security, reliability, performance. Now I forgot the last one. I'm kidding. Cost optimization. Cost, thank you. So in the client, the first thing that I said is, well, the client itself is really a single page. It's an index.html and two really small JavaScript files. One to cast the vote. These are both jQuery files. When you click a button, it sends your vote to the back end based on the button that you clicked. The load results is when we refresh the page, we're kind of showing that tally of votes. So we're going and getting that information displaying on the page. Those are the only dynamic aspects of the page. And that's all that it was. So I said, I've got two statics files. I don't need IIS. Heck, I don't need an entire Windows server to serve these things. So how can I do this cheap, that it'll scale, be secure? So blob storage, it's an object. It's a file is an object. I put it up there. And that's what our release did, is it just updated those files and pushed them to the blob storage. No servers, no spinning stuff down, no spinning stuff up, done. To date, we'll go back and check, but I checked last night, my cost on storage is still 0 cents after running this for 5 days. 0 cents. $0, 0 cents for storage so far in the last 5 days. I'm using so little storage that Azure hasn't cared. No. If you look at the actual cost, I've got to go back through the pricing on it, but you're measuring gigabytes. We're barely using even a megabyte that's out there, right? So this is probably going to run for about a month before I get charged a penny. Something like that. And that's also depending on the type of storage that you use, which I did it on the cheap. Yeah, and consumer pricing as well too. Then I also and again, I didn't do anything with Azure for this part, but somebody asked me what other components I used. Well, I used Bootstrap for the styling and the CSS that went on there that gave me the structure, the color, the buttons, things that I didn't have to do. I used Bootstrap CDN to pull that down. I'm not going to host that. Let Bootstrap host that. They're already doing it. Google hosts that. Use that. I used jQuery. I think I used also Bootstrap CDN on that, and I think they use Google's is what they end up using on it. Cool. Underscore and JSON2, these were two other JavaScript files that are commonly used in building front ends with jQuery and Bootstrap. So I pulled them down and I used Cloudflare's CDN. I'm not going to host it. I'm not going to pay for it. Let somebody else do it. We use that. The other thing too that we didn't see yet, but we'll look at it here, is also use Visual Studio Application Insights. So I put a little snippet of code from Azure, Visual Studio Application Insights, to track my client performance. So I can see how many page loads I'm getting, what the load times are, if this thing's performing or not, is it live, am I seeing any errors? That's coming out from there too. That's my client. Now it was all done in one page, in two JavaScript files that I wrote, but it's using all these other components. I will pay for these. This is free, and so far that hasn't cost me a penny. Cost optimization. And
sorry, what did you pay for again?
The blob storage. And so far it's cost me not even 1 cent yet. Okay, then the back end. We're actually using a couple of different components, and I'll tell you why I picked some of these as I'm going through it. I picked their document database. For one, I didn't need relational databases. I'm actually a big fan of NoSQL. That's a different discussion for another day. But it was very simple for me to put a document together that tracked who we voted for and how many votes they had. And the back end, when it processes it, it actually looks for that record, that document that belongs to Superman or to Spider-Man or to Captain America. It has a little count field on it, and every time that I get a vote, I grab that record, increase that count by 1, and I save it. I had a grand vision for this voting site. I'm making this up as I go along, but requirements, right? So DocumentDB gives me a lot of other things. We'll cover in a little bit more detail later, but the one thing is it gives me pretty much unlimited storage in the sense behind the scenes, Microsoft is handling all the servers behind me, the clusters, the geo-replication, the scaling of that application, so I don't even have to think about it. I don't have to think about my auto-scaling bits. It just grows. The other thing is I wanted something durable because I want some long-term durability on it, and it gives me a pretty good SLA on the durability bits. And the other part, and really again, it was the unlimited scalability, both in terms of storage, CPU. Let Microsoft deal with it. I don't have to learn how to stand up a document database on my own. I don't have to spin up VMs and figure out how to configure my own cluster. It was already there for me. From a business perspective, you have this grand vision of this thing that's going to grow like crazy. It's a good place to go if you don't require relational constraints. Use queue storage. And again, this was for the votes. This was done on purpose to show it off, but also thinking about it. This type of survey that we're doing, even if this thing went viral and we were getting hundreds and thousands and millions of votes coming into this, if I lost 1 or 2 in that queue process, not likely to happen, but if I did, don't really care. If 2 queues came in for the same vote and my back-end process only counted 1 of those because it got invoked twice and they were both editing the same record at the same time, don't really care. It's not a big deal. It was a way for me to scale this out real easily. Another way that I could have done this is I probably could have put those individual votes as record in my document database and then had something else kind of go through and recount those every so often. Or I could have issued, in SQL, the common thing would be is I'd have a table of votes. I'd find my where and do an aggregate on that where for the superhero or the other candidate and count them and do a select on it right when I go to display them. You have to be aware of the way that queue storage works, but basically you're guaranteed at least once delivery on them. So once it's been delivered, it's gone. If for some reason my process on the back end died, there is a way to recover from that, but you have to be, when you're creating your application, you have to be aware of the guarantees that the queue service gives you and how to deal with those. But again, for this particular application, it was quick, it was easy. I can show you queue storage, something to think about. And it's part of the storage services that Azure gives you. So again, from a scalability perspective, the storage service, I get pretty much unlimited scalability as long as I'm willing to pay for the storage, right? It'll grow and expand, and I've got good durability. Don't have to spin up my own RabbitMQ, don't have to maintain it, don't have to configure it, don't have to worry about its security because, I'm not going to say I don't have to worry. I share the security concerns with Azure, meaning as long as I've configured access to my queues for my applications, I don't have to worry about physical access to the servers, don't have to worry about whether the servers are patched or whether everything else that's there. I'm worrying about my application and my data and the security around that, not everything else underneath. The next component, and we'll look at this here in a little bit more detail, are functions. You guys familiar with Azure Functions? No. So Azure Functions was Azure's answer to AWS Lambda. It literally is, and I'll show you this here in just a second, but it gives me some inputs and outputs, and I configure what those look like. And I'll show you guys one here in detail. And then I write a small script that can either be done with a CSX C# script file, JSON, I can write it in Python, I can write it in F#, JavaScript, all those things, and it's a small function that basically processes that input and does something with that output. You guys want to look at one? I know it's code, but we can look at one.
You know if they support C++?
I don't think so. I don't think so. And I don't know if there's any plans for it, honestly, at this point. I don't know if there are any plans for supporting C++ and functions just yet. Yep. It supports Java. I believe it does. Okay, so if we look at these functions, I'm going to look at the first one here, which is cast vote. These are my bindings. So I have The first one here, this is what type this is. This binds it to an HTTP trigger. And basically, there's a URL endpoint. I'm basically creating an API that's saying, give me HTTP requests. In this case, I'm saying put request only, because somebody's going to put their vote at my endpoint, and the direction is going to be come in. The REQ, that's actually a variable that I named in the function that's coming in, and say put whatever context is in that request into a variable called request, short for request, right? REQ. That way I've got full access to what's in there. I have an out binding here, which is also HTTP, which I've named a variable in my function called result, RES. And this is where I can put status code 200 OK, 400 not OK, something went wrong, but I can respond to the web browser on what it's doing. I also have another output here, which is called, which is a queue. I called it a queue item with a queue name of tally vote, and it's going to go talk to that. And this connection string that's here, this is actually in an application setting that's hosted by Azure. This would be your app config file that has the connection string for that particular queue. And so what the function actually does, we'll look at it, this is probably the simplest out of the three, but it's written in JavaScript. That's fine. And it's a simple function that says, I've got a context and I've got a request. I'm going to return a response, and that actually happens here in this context area where I say context response equals status code. This, by default, it responds with just a status 200, which means OK processed. So when I call this context done, it finishes the execution of the function, and we're done. But if you look at what happens here, I'm logging, and I'm saying, hey, I'm processing a request. I check my request, and this is the request object. I check the body for a category and a candidate. So you guys noticed, you guys in the little code that you guys wrote in there, you had a data category when it said superhero, and a data candidate, and you guys put in your superhero. I'm checking that those two things exist. If it does, I'm creating a queue item with that data, and I'm binding it to my queue item that I defined in the function, and I'm done. I've just written an API endpoint. This is literally all the code that I wrote. The other part, and I'll show you guys the interface here in Azure. Azure actually does for me, and then I can pull it down onto my project, which is pretty cool. I will show you right now. Whoa, that did not mean Zoom. Come on. I'm going to see if I'm true to my word. Real quick, check our costs. Man, this has been running for 5 days. And hopefully this won't be too high because it's economies of scale, right? I'm using so little of their storage that it's basically free for me. And Tim's in here too. If he sees this cost go real high, I'm going to be in trouble. But I'm sorry, they've charged me 10 cents. None of it for storage, all of it for compute time on the functions that we played with today. So it's been running for 5 days, and it's been 10 cents out of my pocket. And something that is completely scalable.
I've got an Azure environment. Most of my developers here using that. We're coming near the end of the monthly billing cycle. I just got it through the good
Total usage. Storage, compute time, databases, everything. Now, yeah. But neither here or there. So we were asking about the functions. So for this particular Bootcamp section, we had a couple things. We have our document database. We have an application insights, which again is just tracking analytics on the usage, page timeouts, lifetime. We have our functions storage account. We have a dynamic app settings plan, and this is one of those where, because I'm using functions and all these services where I don't actually need an IIS instance to be hosted for me, I didn't even, basically said, just charge me for the compute time and the storage. Right? So I'm not even paying the $24 a month or whatever it is for a basic app service with an auto scale plan on it because I haven't needed one. And then the functions, which was the question here, is where does this go? So where it actually sits, if you looked at the diagram, I had in there the file storage. In my storage account, there is a directory structure that was created there by functions that has a site directory with a W root directory where each of the functions is an individual directory, like we saw in the source code, and it sits there. It's file storage. It's a new offering from, sorry, file share. It's a new offering from the storage services. Or relatively new. It's been around for a little bit. So again, I don't even really need all the GitHub stuff. I could actually tie this to my GitHub to do automated deployments out to this without even using Visual Studio Team Services. I'm talking, this is where Azure just blows my mind. If I'm thinking just about what I have to build, I can put these components together and really quickly get something up that we can start playing with to see if we're going in the right direction, so I can experiment like crazy before I make any hard, fast decisions on what I'm gonna buy and commit to actually build out for production long term. Love it.
You said this could be a C# file?
Yep, this could be a C# file, or a CSX file to be, which is the C# scripting file. It'll run, it's for the, I want to say right now it supports the .NET Core runtime, so it's a smaller subset of the whole entire, don't quote me on that because I haven't played with it too much. I've been playing more with JavaScript lately than I've looked at CSX. Go, when you get a chance, go to the Azure portal and look at functions. They've got some developer samples in there where they do C# on it. And I think it's just, you have to use portable libraries or whatnot that you're using behind the scenes because for some reason or other, it's kind of what I've seen. But yes, the question is, can I use C# here? Yes, the answer is yes, you can use C#. So there's our function. Then I mentioned the other part where I said, hey, here's the bindings and all that type of stuff. You got a UI for this. Here's my triggers. It's an HTTP request. You got some modes, you got some standard, you got your authorization levels. I can do function level authorization, admin level authorization, so I can secure the crap out of this function. My outputs, it's what I defined. I've got to respond back to the HTTP request, and I got to put something in a queue. So I configure that. I write my JavaScript file. I'm done. I've got an API endpoint. And again, this is brand new and it's in preview, so I'm going back for this. If I do it in the function level, this is actually going to put a key in the query string to make sure that whatever's talking to it at least knows that key. It's kind of a shared key type of approach. The admin one, I got to be honest with you, I don't know. I haven't looked at it. I want to say that it's tied to the directory service in Azure, which is if it's linked to your Active Directory, you should have that in there. But I didn't play with that just yet. And so we could actually wrap this with either a web app service or I want to say even an API app around it to actually do the authentication stuff and whatnot to make sure before they hit the APIs and then pass it through. There's a couple different tricks that we could do that to lock it down. And that's going to be around the application design as well too. So like for example, what would I do differently? Rather than making a simple index.html file, I might actually write an MVC application that handles the authorization and passes some additional parameters to the API, or that configures the client to pass some additional parameters to the API so that I pull the right data, right? The surveys that belong to that customer or the votes that belong to that person, that kind of thing. That would be a production level thing. Right, exactly. Yeah, this is more, again, this was a prototype that I slapped together. And Tim's going to want to know this because he's going to know how much time I spent doing on this. But I think, in time of putting the application together, I think I maybe spent 2 hours on it. Wow. Setting it up, putting it up in Azure, creating the GitHub accounts, setting up, I probably spent another hour setting up the build, making sure that it all worked, and maybe another hour doing a dry run of what we were going to do in the lab today. But total time probably spent on it was about 4 hours. 10 cents in 4 hours. So in all of these get a little bit more different. We've got a JavaScript developer in here. Are you using Node? Yeah. Okay. So you'll love this because you saw that this was Node. The category results guy, this is actually using Node. I actually have a couple other things around it, which are the, let's go to the code real quick, and you probably already saw this. But in this guy here, I needed to use more than what functions gave me. I actually needed to pull in another package from NPM, that's the Node Package Manager, which is kind of like the equivalent of NuGet for C# to pull down a package that has how to access this. And so you'll actually see on the category results, I included a package.json, which is used by NPM to figure out what dependencies I have. And I have a dependency on the document.db NPM package, and I want the latest version. So I actually took this file here, deployed it to the file share, ran the npm install command, and that gave me access at runtime to use the full power of Node in that particular function. Right now, pass some parameters in there to call the document database, tally, get the votes that we're going to send back, and respond with an HTTP request back out with the vote results. Kind of gives you an idea of the architecture here used for the application. It's very simple, but again, I was thinking small, bite-sized pieces to get something off the ground quickly. How can I put it together to compose something? I had another question in here too about Git merges. How do you make sure that you do? So this is where it comes in with the application architecture. As a team lead or as a development manager or software development manager, I'm going to work with my team to say, hey, we've got some changes to the UI. Who wants to take those on? Right? Nitesh might say, yeah, I think I can handle that. I've been playing with Bootstrap. I want to take that on. So he's going to work on that file. And I've got that in my head. And then I can go to somebody else and I can say, hey, you know what? I know that the tally vote function has been kind of chugging through the queue items, and we've been losing a higher amount of queue items than I would have expected. I need somebody to go and look at that. And that might be Javier, who says, you know what, I think I need to look at this from an architecture perspective, make sure we pick the right services. So he's going to go work on that. And now, it's more about the distribution of work that keeps us from doing that. The sample that we used today, because I had everybody go and change the same file in the same line, that's why we had 4 or 5 merge requests. So it's more about organizing the work into small bite-sized chunks that'll make it easy to avoid those Git merges. And I promised you guys a GIF, and I didn't get to it because pressed for time. So let's go back real quick to our presentation here. Okay, the other things I didn't talk about. So we talked about functions. I'm also using table storage, again, from the storage app service for API logs. It's used by default by functions. So when functions kick off, you guys saw in the script that said context.log, and I put some information. That's where that's going. And I can put some retention criteria around my tables to keep the logs as much as I need to. I can do a lot of stuff. But that's our architecture here. File share, this is actually where the code for the functions is actually stored. So the function.json files, the package.json files, the index.js files for each of those is where the functions are actually stored on the server.
Is